With the approach of the year 2000, we at Unisys have been examining our software and hardware to determine the implications of the turn of the century. And wouldn't you know, we discovered instances of date format related issues. Unisys has taken the initiative to accommodate in our software what is required to deal with the two-digit year comparisons and with the year 2000 and beyond, as well as providing a four-digit year capability. However, in the course of our investigation of the year 2000 impact, we found instances of coding techniques most often used with assembler language or MASM programs that could compromise the accuracy of the execution of your applications as soon as 1996. We found instances of the use of these techniques in our exec, in Mapper, in our program development aids, and in the software provided by our third-party software partners. Over the next few minutes, we will discuss what we have called internally the 1996 issue. And based on the experience of our own software developers and third-party partners, we will share with you what the 1996 issue is and how we diagnosed occurrences of the issue, where you should look for the issue in your application code, the tools and techniques we use to correct the issue, and the software levels where the issue is fixed. Lastly, we will ask the question, how can we help? So let's get started.
The 1996 issue comes about from the use of what we call the T-date dollar format. The T-date dollar is an executive request available to assembly language programs and also available to high-level language programs through some generalized ER interfaces that they can call. The T-date dollar format holds a date and time in one word, normally of the form month, day, year, and seconds past midnight. The problem arises when someone takes this T-date value format and moves the year field to the front of the word. When moved to the front, and you get to year 1996, any values of 1996 and beyond appear to be negative. Within the exec, the 1996 issue showed up in a variety of places, mostly in step control, tip file control, some other parts of integrated recovery, one piece of disk pack, removable pack registration, a variety of areas basically. And they were all of the form of someone had taken a T-date dollar, shuffled it so that the year field was in the front, and then proceeded to do arithmetic comparisons on it. And the proper way to deal with this is to treat the field as unsigned or logical, depending on whatever language you're writing in. The changes we've made in the exec for 1996 will have no effect on the client code. We did not change any data formats. We didn't change any fields. We didn't alter any integrated recovery records. So there's no impact from the changes we made. There, of course, will be an impact if the client's code has the same problem as the exec code did.
We were using the, this form of date, we call it the T-date dollar format of date, to represent the timestamps on our audit trail tapes and to represent timestamps elsewhere in Mapper. And we had to go through and find all of those places and change them. In Mapper, there are no customer impacts of the 1996 date. We have actually run Mapper in a 1996 date environment. So we know that Mapper works in that environment. One of the things we might recommend is as an impact that you do take a time in your test period and change the date to a 1996 date and see if your applications continue to hold together.
PADS was the Programming Advanced Debugging System was the only product in the compiler suite that was affected by the 1996 issue. And it did the common technique of aligning the month, day, year format received from the T-date dollar interface. In the case of PADS, it was fairly straightforward because it wasn't involving any data structures or records, so they were able just to change the internal representation and the coding algorithms.
TeamQuest has 21 products that are supported on the 1100 and 2200 systems, and we examined all 21 products, and of those 21, only one product was affected by this issue. The one instance where we found the problem was in the product OSAM,
Yeah, the 1996 issue affects some of the routines in our Star 1100 software package that we have gone through and addressed and made coding changes to correct the problem. As far as our other software at FCI is concerned, we don't think so. We're still doing some auditing of some of the older software.
Our primary language is COBOL, and the vast majority of our code is COBOL. Our philosophy is where we require MASM to extract the data or retrieve the data, we will do that, but we will pass the data back to COBOL for actual manipulation. This way we can put the data into storage structures that we're confident in, whereas in MASM you're manipulating binary data, which may result in erroneous calculations.
We have fixed our coding techniques and logic in our software. Our third-party partners have done the same. Now it's your responsibility to fix the coding techniques and logic in your applications.
It is very easy for customers to feel like they do not have the problem, particularly customers whose primary applications are written in high-level languages. They have a sense of confidence that the high-level language will handle the problem for them. They should not take this too lightly, though. Unless they are 100% certain that their standards over the past has prevented such an occurrence, if they're 100% certain that their programmers and designers have adhered to the standards, then they may be safe. But probably they should at least take a look at their coding, particularly in the MASM area, in the assembler area, to determine, are these date formats being retrieved and are they being manipulated? After that point, then they can narrow down to specific processes that may need to be analyzed closely. The real important issue here is for the customer not to shrug it off as not having the problem because he is primarily a COBOL shop or primarily a Fortran shop at some high-level language. The customer really needs to make a diligent effort to take a look at the coding to ensure he does not have the problem.
I believe the worst case that could happen is if they have a large database that has stored this value out in the database, they're going to have to either restructure the database or put coding sequences in that correct it when they reference the date. The implications to a client if they don't correct the occurrences of this in their code is that when the clock rolls over to the January 1st, 1996, their applications may be executing incorrectly, and they may not be a visible failure, but just incorrect results.
What could be the consequences of date format related issues? ATMs cease to function correctly. A bank transaction, or for that matter any transaction, is processed out of sequence. Planes not removed from service because of scheduled maintenance. Railway accidents occur due to automated switches being set to wrong date and time. Orders can't be filled because inventory has expired. Insurance claims refuse when tests cannot be reconciled with admission dates. Electrical switching systems may not turn on power network sources on schedule, causing massive blackouts. These coding techniques, used extensively in the late 60s but still used in the 70s and early 80s, should be a cause of concern to our clients.
And when year 2000 rolls around, the whole industry is going to be in for a shock. We have found several places in the exec that assumed 1900. We fixed those. We know of many, many instances in user databases and user applications that also assume 1900. And that's not just true on 2200s, that's true on A-series, that's true on Unix, that's true on every box we've ever seen from every manufacturer. The year 2000 problem is more widespread than the year 1996 problem. It shows up not just in assembly language code and not just the older languages. It shows up in modern languages, it shows up in C code, it shows up in COBOL code, Fortran, plus anywhere that anyone has made a decision to store a year as a two-digit value. There's a problem. And people have been doing that right up, well, in fact, they're still doing it. We still see relatively new application programs being written with two-digit year fields. This is a widespread problem, and the only way to fix it is to change the applications, unfortunately. Either logic has to change to properly interpret 2-digit years, or the data itself has to be expanded to hold 4 digits.
We were well aware of the 2000 issue simply because we've been working with the product so long and understand the impact of a 0 date. Our first step was to identify those programs that had user input, so we can identify when the user inputs a 0 date as opposed to no date. Our next step was to, in programs that manipulate that data, to determine is it a year 2000 date or a date prior to that. The third step would be to test what we had done to ensure that it works for both the 20th and the 21st century. We could not take the approach that if it works for the year 2000 that we're safe. We also had to do regressive testing to ensure that it worked for all years, both before and after the year 2000.
Support for the year 1996 and year 2000 changes to our software is available for the various 1100 and 2200 systems under the following system-based releases. Unisys software developers will generate a problem list entry, PLE, for each year 1996 and the year 2000 issue. Problem list entry information can be obtained through Unisys client support services in accordance with standard support agreements throughout the world. A special problem list entry contains the latest software product matrix for the year 1996 and the year 2000 information.
In some instances, we'd start out by looking at the user documentation to see where dates were displayed or entered by the user or manipulated in some way. And that gave us an idea possibly of where then to look in the source code for instances of dates.
So the first place to start looking is assembly language code, and then anyone that uses ER to T-date dollar through the general ER interface mechanisms available in the high-level languages. And again, you should also look at any specialized utility programs you have that might examine program files or the master file directory or integrated recovery records. Another place to look for issues is go into your database schemas, look for field descriptions that show a time-date value stored in a single word and typed as a signed integer.
Call and IACall are tools which can be used to search for occurrences of strings within source code files. First, you use call to process the source file, and that creates an output file which is then used by IACall to search through the source code. IACall, then once you've created the output file from call, you use that to locate strings within your source code file. And for example, if you use ERT date dollar, you can search for that string within your source code, and then you find all the elements where it occurs, and you can also then use IACall to go directly to the line of code which contains that string. Once you have found your string with IACall, you continue using IACall to search for other strings that the logic has led you to discover. And for example, with the ERT date dollar, you find out where you have stored the date, and you continue your search along those lines to see if you have stored the date and manipulated in such a way that would cause the 1996 problem by putting the year in the top sixth of the word.
In order to find the occurrences, we primarily relied upon IACall to wander through the exec looking for all instances of T-date dollar and following the data wherever it got stored.
We chose to change the date representation in all places to a consistent form, so that we do not use the T-date dollar format in Mapper. What we chose to do was to go to a Julian date format for all of our representations and completely obviate the problem.
We went about analyzing our code by first analyzing some of the standards and procedures that we had implemented over the years to ensure that these standards and procedures did not bring about a problem in this type of area. We next actually analyzed the application code to ensure that executive request or data manipulation did not produce the error that we were not unaware of. The strategy for 1996 was an analysis more than it was a correction. We wanted to have the confidence that our code did operate as we thought it should, so we ran our test using 1996 dates as well as a manual analysis of the code. We did not find a problem in the 1996 area, but it helped prepare us for the year 2000 issues, helping us to identify code and programs that might be affected.
The best technique is to take a test period and run your code in a 1996 date environment. Tell the execs that the date is a 1996 date and see if your application continues to function.
There are some techniques, and I would recommend to everybody that they might want to read this booklet that's Unisys has published about the year 1996, how it can affect your applications, where they talk about both the year 96 and the year 2000. We offer two products specifically to the Unisys customers, the 2200 customers. The first is what we call Safe 96. Safe 96 is a risk assessment. It is meant to determine if the customer really has any incidences of the 96 situation. The Prevent 96 product is involved or involves actually resolving year 96 problems in the assembler code. The first step is to address those issues which we have found in the Safe 96 product. The next step, though, is to determine if there are any other short-term problems with the year 2000 that will crop up in the year 1996. Our goal is to make sure that the customer goes through 96 and has time to address those other issues. The activity of Prevent 96 will highlight the steps that will be necessary to follow on work to address the year 2000 problem. And they may be an application sizing where a single application will serve to put the organization on notice of the cost. Or they may require a portfolio sizing which will be used to identify how many resources are going to be required. Or we may move directly into a conversion where the problems are immediate and will affect the business in the very short term, year 96, 97, 98. And we'll want to address those immediately. Unisys and Data Dimensions are going to make this brochure available to all of the Unisys sales representatives. This brochure will be distributed in quantity so that they can be handed out to the customers. This brochure identifies very quickly the nature of the 1996 issue, describes the Safe 96 product and the Prevent 96 product, and very briefly discusses what Data Dimensions does for the Millennium update. How would a customer get in touch with us? I think that the best way of doing that is to contact the Unisys representative first.
Information Services provides on a worldwide basis 3 services to our clients. Number one is an assessment of what the issue is, or the magnitude of the issue in their particular account. Number two is a planning service to develop a plan to address that issue. That is, what's the magnitude of resources required. And number three is to provide resources to solve the problem, to actually get down into the code, the logic, and help customers resolve the issue for their particular installation. The primary way our clients get in touch with the information services resources through their client relationship manager. Alternately, they would deal with their information services or IS principal or senior manager that services their account on a normal basis.
Remember, the clock is ticking. January 1st, 1996 will be here before you know it.